Hello. In this video, we are going to see the manual calculations behind the ARIMA model. First, we will import the necessary packages and the dataset required for this demo. We're going to use the air passengers dataset. It consists of 144 rows of data with monthly frequency starting from January 1949 till December 1960. We're going to use the ARIMA model. ARIMA model is a time series forecasting model which stands for autoregressive integrated moving average. It has basically three parameters, P, D, and Q. P determines how many past values from the dataset are used to predict the future value. D determines how many times the data needs to be differenced to achieve stationarity. Q determines how many past prediction errors are used to determine the future value. In the first scenario, we will set P and Q equal to 1. There is no differencing, so D is equal to 0. This means the future value will be dependent on the single past value and also on the single past prediction error. We are going to do a two-step forecasting. When we run the ARIMA model for these PDQ values, we get the forecast as 454 for January 1961 and 443 for February 1961. Now we will calculate manually and see how these values were achieved by the ARIMA model. We will look at the formula. Since there is no differencing, first we need to calculate the constant term, which is the mean value of the time series. Now the difference between the future value and the constant term will be equal to the autoregression coefficient times the difference between the past value and the constant term, plus the moving average coefficient times the error made at the prediction of the past value. In this case, the value at January 1961 will be dependent on the value at December 1960 and the error made during the prediction of the value at December 1960. By printing the model summary, we can get the value of the constant term, autoregression coefficient, and moving average coefficient. By printing the model residual values, we can get the error made during the past predictions. By substituting the constant term, the autoregression coefficient, value at December 1960, the moving average coefficient, and error value made during the prediction of December 1960, we get the value of January 1961. We can observe that the manual calculation result is the same as that of the ARIMA forecasted result. During the calculation of the February 1961 forecast, the moving average part will be 0, since the error made during the prediction of January 1961 value is still unknown. Therefore, the forecast of February 1961 will be only dependent on the value of January 1961. We can observe that the manual calculation result is the same as that of the ARIMA forecasted result for Feb 1961 as well. In the second scenario, we will make D equal to 1. This means all the values in the time series will be subtracted with their previous values. Differencing is usually done to make a time series stationary. This time, the difference between January 1961 and December 1960 will be equal to autoregression coefficient times the difference between December 1960 and November 1960, plus the moving average coefficient times the error made during the prediction of December 1960 value. When we rewrite the formula to calculate January 1961, we get output as 476, which is equal to the ARIMA forecasted value seen above. During the calculation of the February 1961 forecast, the moving average part will be 0, as mentioned earlier. Therefore, the forecast of February 1961 will be dependent on the value of January 1961 and also December 1960 due to differencing. In the third scenario, we will also enable the seasonal part. In addition to small PDQ, we also have 4 additional parameters, capital PDQ and M, related to the seasonal part. We will set small p and q as 1 and small d as 0. We will set M as 12, indicating annual seasonality, and also capital D as 1. Since both seasonal and non-seasonal differencing is enabled, and also small p is enabled, forecast for January 1961 is dependent on the following values. January 1960, due to the seasonal differencing. December 1960, due to small p equal to 1, and also due to the non-seasonal differencing. December 1959, due to the seasonal differencing. November 1960, due to the non-seasonal differencing. November 1959, due to the seasonal differencing. By substituting all the necessary values, we get 444 as the output, which is equal to the ARIMA forecasted result. Hope you enjoyed the video. Thank you, and see you again in another video.